This question is from the topic calculus. Here, they say that we have a closed cylinder with base radius r centimeter, its height is h centimeter, and its volume is v centimeter cubed. It is also given that the total surface area of the cylinder is 600 pi and the volume, radius and height all can vary. For the first part of this question, we have to show that the volume of the cylinder V can be written as 300 times pi times r minus pi times r cubed. And for the second part of this question, we have to find the stationary value of the volume, as well as we have to determine the nature of this volume, that is whether it is the maximum volume or the minimum volume.
So let's move on to solve the first part of this question. Here we have to show that the volume can be written as 300 times pi times r minus pi times r cubed. But we know that the cylinder of a volume is pi times r squared times h. But in our V there is no h. So how can we remove h? It's simple. If we can represent h in terms of r, then we can easily write the volume without h only in terms of r. So at first we have to represent our height in terms of r. But how can we do this? We can use the information of total surface area of this cylinder. The total surface area of the cylinder is given as 600 pi. Using this information, we can represent h in terms of r. Here at the right side, let me draw a closed cylinder so that I can show you how many surfaces a closed cylinder have to get the total surface area. So now this is a cylinder of radius r and height h centimeter. Now at the bottom we have two circular surface, and we know the area of a circle is pi r squared. So let me write those areas: pi r squared at the bottom, pi r squared at the top. And this part is known as curved surface area, and the curved surface area of the cylinder is 2 times pi times r times h. Adding all those areas, we can write the total surface area as pi r squared plus 2 pi r h is equal to 600 pi. Now in the next line we can write 2 pi r squared plus 2 pi r h is equal to 600 pi. From the left hand side, taking 2 pi as common factor, we can write 2 pi times r squared plus r h is equals to 600 pi. This pi cancel out this pi, and 600 divided by 2 is 300. So in the next line we can write r squared plus r h is equal to 300. Now subtracting r squared from both sides, we can write r h is equals to 300 minus r squared. Now let's divide this equation by r. So finally we can write h is equals to 300 divided by r minus r. So we have represented h in terms of r. Now we can substitute this value of h in the formula, which is v is equals to pi r squared h. So let me write that formula first. V is equals to pi times r squared times h. Substituting h in the next line, we can write v is equals to pi times r squared times bracket open 300 divided by r minus r bracket closed. Now let's multiply. So in the next line we can write v is equals to 300 times pi times r minus pi times r cubed. So finally we have shown the volume can be written in the form of 300 pi r minus pi r cubed. Now let's move on to the second part of this question. Here we have to show, we have to find the stationary value of the volume, and we have to find the nature of this volume, that is whether it is the maximum volume or it's the minimum volume. In this question it says that the volume V, radius r and h all can vary. We know that when volume is stationary, at that very moment dV over dr is equal to 0. That means we have to differentiate the volume with respect to r. So let me write the relationship of the volume and r that we got from the first part of this question. That is, V is equal to 300 pi r minus pi r cubed. Now if we differentiate both sides with respect to r, in the left hand side we can write dV over dr, and in the right hand side we can write d over dr of 300 pi r minus pi r cubed. Now in the next line we can write our dV over dr is equal to 300 pi is the constant coefficient and the differentiation of r is 1, so we can write 300 pi minus the differentiation of r cube is 3r squared, so we can write 3 pi r squared. As the beginning of the solution, we have written that this when stationary V is stationary, dV by dr is 0. So using that information for a stationary volume, we can write 300 pi minus 3 pi r squared is equals to 0. Now rearranging this equation, we can write 3 pi r squared is equal to 300 pi. So let's cancel out pi from both sides. 300 divided by 3 is 100. So r squared is equals to 100. Now let's square root both sides. So we can get r is equals to 10 centimeter. So we can say the volume will be stationary when the radius of this cylinder will be 10 centimeter. So using r equals to 10 centimeter, we can write V is equals to 300 times pi times 10 minus pi times 10 cubed. So it will be 3000 pi minus 1000 pi. So V will be our 2000 pi. So we have found the value of the volume when it is stationary. Now we have to determine if this 2000 pi centimeter cube is the maximum volume or the minimum volume. In order to do that, we have to differentiate our first derivative, that is dV by dr, once again with respect to r. So let me write dV over dr, which was 300 pi minus 3 pi r squared. So now if we differentiate with this equation once again with respect to r, we can write d over dr of dV by dr is equals to d over dr of 300 pi minus 3 pi r squared. So in the next line we can write d squared V divided by dr squared is equals to 0 minus 6 pi r. Now it will be negative regardless of any value of r, as the radius obviously will be positive. So we can write it will be less than 0, as we know that radius is always positive. So and we know when the second derivative is less than 0, the nature of the stationary point is maximum. So we can write the volume is maximum. maximum when when it is stationary, that means when the volume is stationary. Okay, now we have completed this question. Now let's move on to the next question.